Alright, let's look at part 2 of this, and we're going to basically try to finish this off. So what we had before is we had some box was being suspended by 2 ropes, and the box had some mass that was given to us. And we know these angles, so we know this angle theta, we know this angle phi. Question is what are the tensions in the rope, or these forces, F1 and F2. So we're just going to look at how to set this up and examine some of the potential issues to explore. So the basic idea is we're going to balance the forces, left versus right and up versus down. So in the case of left versus right, we're going to take all the forces that are in the xy direction and add them up, and they should add to 0. So in this case, we've got 2 forces in the left and right direction. We have the force from this component, and we have the force for this component for F2. So if I balance those things, what do I have? I'm going to have, let's see, so this is going to be minus F1 cosine phi. This force right here is to the right, so it's going to be positive. It's going to be plus F2 cosine theta, and that has to add up to 0. Okay. Now if I look at the up versus down, what are we going to have here? So in the up direction, this is going to be positive here. This is going to be positive here, and this is going to be negative. So if I add these up, let's see, this is going to be what? F1 sine of phi. This is going to be F2 sine of theta, and this is going to be minus mg. In the downward direction, that all has to be 0. So I've now got 2 equations, 2 unknowns. Let's rewrite this. I've got minus F1 cosine phi plus F2 cosine theta is 0. The other equation is F1 sine phi plus F2 sine theta, and if I add the mg to both sides, I get that. So I'm going to back up and try to think about this in a different way. So I can think of this now, I can think of this F1 as being like an x. I can think of F2 as being like y. So if I break this up, I think about what's the relationship between F1 versus F2. Let's look at this first equation. What does this give us? So let's solve for F2. I get F2 cosine theta. If I add that to both sides, is F1 cosine phi. Let's throw some numbers in here just to see what they look like. So let's suppose phi is pi over 3 and theta is pi over 4. So if that's the case, what do I get? I'm going to get F2, this is going to be 1/2. It's going to be F1 cosine of pi over 4, then is going to be what? Square root of 2 over 2. So I get F2 is F1 times square root of 2. Okay. So let's see, what does that mean over here? And basically, so if this is my y, this is my x, this is going to give me a straight line. And any point on this straight line is going to balance this equation, and this first equation will be correct. Now let's look at this second equation, see what happens. Bring this down here. So let's see, so this is going to be, I'm going to solve for F2 again. F2, so sine of theta is going to be square root of 2 over 2. What did we say? The mass was 30. Acceleration due to gravity is 9.8. We're going to have minus F1 sine of phi is square root of 3 over 2. So if I multiply both sides by 2 and divide by square root of 2, I'm going to get whatever this number is. And this is going to be what, minus F1 square root of 3 over square root of 2. So now this is going to be, right, so this is going to be have a y-intercept that's positive and negative slope. So it's going to look something like this. So anywhere along this line, this equation is satisfied, and it's going to be true. I want to find the magical place where f1 and f2 are true for this line and for this line, and so where those two things overlap, that's going to be the solution to my system. So I'm basically trying to find the intersection of these two lines. What are the possible things that could go wrong here? So just in general, what's going on? How do we look at this thing? One thing to note, we can ask for what situations do we have solutions? So if we think about our straight lines, what can happen? We could have a situation where the lines don't match, and I'm going to have no solutions. I can have situations, right, where the two lines overlap and I have infinite solutions. Or I can have situations where the equations basically don't make sense. So what's going on in these situations? So physically, how do we think about this physically? I can have a situation, for example, here, everything balances out and it made sense. What happens if my angles are such that they're f1 and f2 are parallel with the horizon? Right, so if that happens, this diagram now looks like this. If I go to try to balance this, basically f1 has to equal f2, but there's nothing counteracting mg. There's no forces in the up and down direction except for mg, and there's no way to balance this, so I'm going to have no solutions. And so there's a problem here in that there's some relationship between f1 and f2 that allows me, or does not allow me to get a solution here. So basically in this situation, there's no solution. Okay. What happens then if both of these things are going straight up? Oops, that should be f1, sorry. So that's what f1. And now I'm going to have this thing right here, so that's my f2. And I've got mg. In this situation, what's going on is that there's nothing in the left or right direction, so there's nothing to balance that way. But in terms of the up and down direction, I got f1 and f2 has to equal mg. And you give me anything for f1, I can just figure out a new f2 that'll make this work. So in this case, any time that f1 plus f2 equals mg, right, then this thing will balance, and there's going to be basically infinitely many solutions. Right? There's not a single way to make f1 plus f2 equal mg if there's no other equations. So basically what can happen here is I can have one solution, I can have no solutions, or I can have infinite solutions. And the questions we're going to ask over this semester are, how do we figure out, do we have a nice case where we only have one solution, or is it impossible, or is there infinite solutions? And we would like to know in advance, before we try to solve this thing, what the heck is going on. Because if we get down and we try to solve something, we want to know that there is a solution. If not, we basically have to go back and we have to relook at the situation and add some other constraints or change it somehow, right? Because in this situation or this situation, we've somehow designed this apparatus that is not going to give us what we want, right? So just asking before we try to start solving things, is this a good design, is an important question.